Today we're going to do an activity to investigate pulleys. A pulley is a wheel that has a string, a rope, a belt, or chain passed over it so that you can apply an effort to one end and attach a resistance to the other end. In a single fixed pulley system, one pulley is permanently attached to the device. The rope is passed over the single pulley and attached to a resistance at the other end. Since there is only one strand holding up the resistance, it has one support strand. The other strand of the pulley system is the effort strand. Just like a lever, the mechanical advantage of a pulley system can be measured by determining how far the effort moves and comparing it to how far the resistance moves. To be able to measure these distances, we will need to indicate a starting position for both our resistance and our effort. Lower your resistance all the way to the ground and hold your effort string so that it's tight. While your resistance is resting on the ground, place a piece of tape on the effort strand right below the pulley. This piece of tape will allow us to measure how far the effort moves when we pull down. In this case, the effort moved from here to here. If the resistance is on the ground when we pull down, we'll be able to measure how far the resistance moved by measuring how high off the ground it is. So this is how we're going to make our two measurements. Pull straight down on the force sensor so the tape moves about 30 centimeters. Use your ruler to measure that and hold it. Record this 30 centimeters as your DE, or the distance your effort moved. Remember that we need to divide this by 100 so that it's in meters. Now, without moving the force sensor, use the same ruler to measure how far the resistance moved. Resistance moved 30 centimeters also. So you'll record this as your resistance distance, or DR. And again, you're going to divide it by 100 to convert it to meters. Before you measure your forces, be sure that you zero your force sensor. Attach your force sensor to the effort strand and pull straight down, reading the force off of your force sensor. Again, remember to be sure your strands are hanging straight down and they're not rubbing on anything or getting caught. This force sensor is reading about 1.2 newtons force for the effort force. Now you'll record this as your effort force in your data table. Next, use an S-hook to attach the resistance to your force sensor and measure this force. And it's also 1.2 newtons. You'll record this as your resistance force in your data table.